Hello, everyone, and welcome back to this afternoon's session. I hope you all had an enjoyable lunch break. Sorry, I'm just trying to get the webcam in the right position. Just before we get going with profit, there's you'll see in the Slack module 9 forecasting window, I have just pasted the link to the documentation for forecast tools. And one thing I just wanted to point out for anyone who may be considering doing a forecasting project. Within the documentation, under the quick start, there is a link to automatically selecting a naive model to use as benchmark. And if you follow the instructions within this will show you how you can use one of the functions within forecast tools, auto naive, to actually assess the data set and decide which is the best of the naive models to use, rather than having to try each and every one of them individually. I just thought that may be useful for some of you if you're interested. Anyway, to get on with this afternoon's session. So as I said, today, or this afternoon, in fact, we'll be talking about profit. Now, the great thing about profit for the R files in here is that it is available in both Python and in R as well. And it is great for dealing with daily level data, especially within the health sphere. And I'm just going to go into... sorry, I'm just going to move this window out of the way so I can see what I'm doing. So just to show you very quickly, if you go to that link that was on that web page, you get to the GitHub repo, which has more information about the Profit library. It's got information on how to install it, getting started in R as well as Python, and it also has a link to the paper that was published that talks about how it was used. So feel free to go away and have a read here if you want some more information. Okay, so to kind of go back a step, what was the motivation for profit? Why did Facebook decide that it was worthwhile in having its team analyze it? Well, basically, they decided to use a load of tried and tested old ideas, but implement them in a really nice and easy to use package that was very accessible, even for the most novice users. It really does often, modern business forecasting at a daily level. And the importance is that it can actually be used to kind of go down to a more granular, lower level, so hourly level. But it also can be used at a higher or more aggregated weekly level data as well. And the great thing is that it allows for multiple levels of seasonality. So not just seasonality within a week, within a year. It also allows you to account for special events or holidays. And these can be called spiky events. And you'll see why when we look at a time series. And one thing that they realized, our good friends at Facebook, is that there's lots of data available. However, in reality, kind of forecasting and the time series expertise required to do something constructive with it is limited. So lots to do, but not enough people to do it. It was also quite fiddly as well, and lots of statistical knowledge was required. And so what they decided to do was come up with a package that made it very easy to use with just a few buttons and knobs to tweak in order to fine tune, and hopefully its simple interface makes it more widely accessible. And in actual fact, the results of it are pretty good. So you'll find that it is used quite a lot out in the real world, just because it works so well, and the forecasts it derive are pretty good. So here we are looking at the ambulance data again. So this is the number of calls that resulted in one or more ambulance dispatches, as you can see, ranging from 2014 through till 2019. And is there a trend? Kind of, maybe it's a slight upward trend, possibly. Are the cyclical patterns? Well, yeah, it kind of seems like it kind of goes up, down within each year, maybe. But one thing it does point out are these red dots. So this is New Year's Day, and these are the spikes. So normal forecasting methods would not really be able to help you with these kind of once a year or once in a cycle spike, given the spikes are so exaggerated. If you look at, we're down here around 2000, it jumps up to 2600. They're always quite significant. And that's one of the benefits of profit. And when we say, is there a weekly pattern? Unfortunately, we've just got so much data on the screen that it's quite hard to unpick if there is or if there is not. Trying to divide that into a 50 seconds to look at it would be quite difficult to do. So if we break it down and actually look at the monthly seasonality, and so we've got these box and whisker plots here. For anyone who's not too familiar, if anyone's not too familiar with those, I've left the link so you can go and read more about them. But essentially, that says for all of the data available, let's just get all the January data, so January 2014, 15, 16, 17, and let's look at the distribution of the values within every day within that January. So we can see the median or the middle value will be this purple line here, as we can see here. You've then got the upper quartile, lower quartile, and then the outliers. So these dots at the top will be these New Year's Day events, because you can see they sit so much further above. But what does this tell us? Well, we can see that, December is definitely, as a whole, busier for the number of daily responses compared to other months. And there seems to be a bit of seasonal variation, quieter in April, August, September, but not too sure. Then if we have a look and we look at the daily level, so this is picking up every Monday in that period, and we can see that the weekends definitely tend to be busier. The median is sat higher. And then with the remainder of the week, they just kind of follow a U-shaped pattern. So, quieter in the middle of the week. So we're starting to get a few more insights here. And so the great thing about profit is that it is an additive model. And simply what it's doing is adding all of these components together. So three of these, you'll recognize the terminology from this morning. We've got our overall trend, and that's, which direction of travel. We've got our seasonality, so within each 12-month period, say, what's the pattern tend to do? Are the holidays, so those spike events, so New Year's Day, as we've already seen. And then we've also got these IID errors. Now, these are independently, identically distributed errors. And this is where profit goes against other forecasting literature, in that, other literature believes that there's a lot of autocorrelation going on within each kind of time series. Now, autocorrelation, you'll remember we said that the sales on a Thursday are relative to those on a Wednesday, which are relative to those on a Tuesday. And they also believe that errors could be correlated into all of the other prediction. Now, profit is assuming that no, the IID errors are completely separate to one another, and you'll see the benefit of that as we move forward. Now, the other good thing, even though that this is an additive model, we just add these together to get the final estimate or prediction, they can be non-linear. And so obviously that has an advantage. You can kind of mix and match as you're going along. So the trend may be linear, but seasonality may not. So there's obvious benefits when you consider those. Now, what profit does, I talked about it, adding those first two together, and it says the IID errors are uncorrelated. It performs something called whitening of errors. Now, this is where it's trying to remove all of the autocorrelations and patterns within the errors. Once it looks at these first three components, the trend, seasonality, and holidays, therefore leaving just errors that are uncorrelated. They don't bear any relationship to anything else that's going on within the data. Now, with the trends, we're going to break each of the components down into each different step. So the trend, and this can either be a linear model, and as I say, it'll be piecewise. So that could be have one segment that, has quite a steep incline, then it can get flat for a bit, then down a bit. And so it doesn't have to be one straight line. It can be different segments of a straight line, all concatenated together. And it just looks for the different change points in there. Or you can have a logistic model. And this is where the values taper off over time. So it's not just continually going up. It may go up and then kind of peel off. So the change or the trend points between these different aspects or components of the trend are automatically detected by a Bayesian approach. And what Prophet does is it kind of throws loads of these change points in there and then plays around with the parameters to see, are they true change points? Is there really a variance, or is it not? Is it all just part of the same trajectory? And then once it's picked out the ones that it's sure that are genuine change points, it will kind of move on from there. And again, it's probably easier to see when we look at the decomposition shortly. We've then got seasonality, and again, this is also detected by Prophet. And you can have seasonality at different time intervals. So with the month of the year, and this is modeled by what's called a Fourier series. So if you remember from high school maths, you've got your sine and cosine waves. It basically uses these different types of waves to fit a curve to the data. And for anyone interested, there is a link in the slides, so you can go and see more about that. It's got day of year seasonality, again, also modeled by a Fourier series. But then when you get to the day of the week, it uses dummy variables or categorical variables, and these are similar to what you would see in a regression analysis. So these would be binary, so zeros or ones, you just turn them on and off. And again, that makes it very, very good at fitting the seasonality at these different levels. Then you've got the holidays. Now, again, the great thing about Prophet, it uses the public holidays that are available in a particular library called the holidays package, which I've got open, we can have a look at in a second. So both within the United Kingdom as well as internationally as well. And so it already has the dates of Christmas Day. If it's, let's say it falls on a Sunday, but it's observed on a Monday, it will have both values in, Easter holidays, St. Patrick's Day, and all of that jazz. They're all in there, so it has something to go and assess it against. And it's very, very flexible in that it will allow you to add your own. And later on, we will have a go at adding our own. So we'll actually add in Black Friday, the sales events. Let's see if that has any impact on the time series data we're going to be playing with. And similarly to the day of week, these are modeled using dummy variables. But again, the great thing is this is all done under the hood, so you don't need to worry too much about it. The only thing I will say is that you don't want to, if you assess a holiday that you've added and you realize that actually it's not making much of a difference, take it out, because otherwise Prophet will think it's a kind of obliged to use it and will probably mold the data more than it should, if you like. And another bonus is that you can, if you want, add in additional regressors into the Prophet model. And so, examples maybe, and could be used in other things, looking at weather and air quality may be important for if you're modeling respiratory attendances. You could have performance of other related health systems. How are they doing? Because that may impact how you're doing. For example, ambulance response rates may be impacted to ED presentations, or a lad combination of the above can be used. But as I mentioned this morning, just be very, very careful, because if you need something that needs, one of the regressors that you're using, or one of the other additional data points that needs to be used to come up with the thing you're forecasting, if they too need to be forecast, you're introducing more errors or potential for error, and you need to think about what's the availability of the forecast version of the upstream data points required for your downstream processing. So it may not always be that straightforward. So looking at our ambulance data again, so with Prophet, it gives us our decomposition charts like we saw this morning. And so with our ambulance data, we can see there's a few distinct areas. So we can see there's probably a change around here because the trajectory changes. Another one here goes down and again up. And as the body of text says, you know, a smooth trend with little variable or variation implies it's going to be similar into the future. So smooth trend reduces uncertainty, whereas if you have lots of trend or change points, that can introduce more uncertainty into the future because you don't know what's going to go on. And that's why you can see the prediction interval, you know, kind of grows as we get into the future forecasts to the right. As I say, it's not completely linear, and yeah, we've introduced that uncertainty because of that non-linearity. Then we've got our day of week seasonality as we fit our dummy variables. And again, you know, remember when we looked at those box and whisker plots, we saw that there was the U shape in the middle of the week. Well, you can see that U shape kind of follows through here. Wednesdays tend to be that, you know, have lower values than the earlier in the week, and certainly the weekends. Actually, sorry, yeah, you can see Monday through Friday, and then Saturday, Sunday, the weekends are higher. And then we've got our monthly seasonality. And as you remember, I say that this is fitted with the sine and cosine waves, or the Fourier series. And you can see that it just, you know, follows along here, or quite curvy and nice, you know, peak towards the end of the year, quieter in the summer months. Now, this is interesting. Now, this is when we're looking at the holidays. If we have a look, we can see on average a New Year's Day, and you'll remember those red spikes in the original time series data. Well, they're, you know, adding 100 on average 140 extra calls every day. So it's quite important that Prophet is actually able to model these particular holidays, given they have such a big impact on the future forecast. You know, each New Year's Day, it needs to put 140 extra calls on the prediction that it would have done at other times of the year. And so when we look at it as a whole, we can see we have our composition, you know, our trend, our seasonality, our holidays, and what we have over here. We have our dark blue line, which are point forecasts. So what the guess was, this would be the middle of the forecasting distribution. We have the light blue lines, and this will go out to the 80% forecast interval. We've got the black points are actually the observations. This is the actual number of calls, the test data, if you like. And then in the future, we forecast ahead, and you can see the forecast runs forward. It still accounts for the peak, you know, on New Year's Day, but you can see lots of variation. So it does look similar to the actual data to the left of it. And as you can see, the left is the fitted model, right is the forecast, but you'll actually have a play with this in the lab. And because Prophet uses Plotly, that means you actually get interactive graphs, which means you're actually able to zoom in on smaller parts of the graph. So let's see, where are we? Okay. So what we'll do now, we'll go straight into our code alongs, if that's okay, of which there are 3, and we'll work our way through those. And the first step actually is quite interesting in that we have to prepare our data to feed it into the Prophet model. So it does like it to look a certain way, and that's just because it was created by a different set of people. But you'll see what I mean when we get going. So feel free, you don't have to follow along. Again, all of the code is provided for you. There are no omissions, so you can run this afterwards. You just want to focus on the screen. But in this first code along, we are first of all going to import our standard libraries for this type of exercise: NumPy, Pandas, and Matplotlib. Next, we are going to have we're going to import our respiratory admissions, and again, I'll just show you what they look like. These are daily level data. So the year 2015, August the 1st, and there was 13 respiratory admissions. We're going to set that as our Y train. We are going to use the PD read CSV, grabbing this CSV. We're going to parse dates. We are going to do the date first because this is the UK format. And the index column, we're going to pick up the date column. And then we're going to set the frequency to D for daily level data. So let's just have a look at that. And so if then we just have a look at the top of that, just the head, we can see we've got our data as our index, daily level data, and our respiratory admissions as the main value. So if we then go on to plot the data, we can see very hard to really see a trend overall. There does appear to be some seasonality, but there's quite a lot going on. It's difficult to unpick what's what. But now we're going to wrangle the data and get it into a format that Profit wants to see. Now, Profit likes two columns in its data, a DS for the date or the date series for the time series, and then Y for the Y value that you're going to predict. So DS is the timestamp or the date stamp, and then the observations. So to do that, what we're going to do, we're going to turn our index from the Y train above. We're going to create a data frame and call that Profit train. We do that. So that just has a single column in a data frame, date. The shape of that, just to see, we've just got our 1,095 observations. And to that Profit train, we're going to add a brand new column entitled Y. And into that column, we're going to pull out the Y train. So we're going to pull up this Y train, the only values that there are, and we're going to convert that into a NumPy. And when we do that, we then end up with our date and our values. Then we're going to rename them. So as I say, Profit is expecting two columns, one entitled DS and the other Y. So we're just going to relabel those here. And we can see we've now got our DS and our Y. And obviously, we've done that in a stepwise manner. There is a function here for you, which you can recycle in the exercise. And this just pulls in the data frame or the Y train, gets the index, gets the data from it, adds that into the Y column, and then renames it. So we can instantiate that user-defined function. And then just to make sure that it works, we're going to create a new object, or sorry, a new variable called YP train. And it's just going to be the data frame using that above function. As expected, two columns, DS and Y. So if we put that all together, just in a single cell, we're saying what data we want to use. And we are going to create a Y train variable with the read CSV, pulling in that URL, passing the dates, setting the frequency to daily, and then we are going to use that user-defined function to pull in that training data. And there we go. So in one cell, we've gone from having that raw CSV to having the training data. So hopefully that all makes sense. If you try to feed in columns other than DS and Y, you may have problems, and hopefully that could be a quick troubleshooting for you. So next, this is where it gets interesting. This is where we're actually going to create our own very basic Profit model. So in addition to the standard imports, as we saw in the previous notebooks, we are going to start pulling in Profit as well. So we're going to import Profit. And then we're going to import the Profit class, which is required for the forecasting. And then also, as I mentioned, the interactive charts. Well, this is why we're going to import Plotly and Plotly components Plotly. And we're just going to check the version on this. So it does need to be version 1. If it's version 0.7 point something, it may be called FB Profit instead of Profit, which is a little bit annoying. But again, possibly some troubleshooting, especially if you use Colab. It's worth knowing about that. Then we've got our utility function, which we've seen previously. So I'll just instantiate that. Then we'll load and pre-process the data. So this is respiratory admissions daily. There we go. So run that, and we'll just have a look at the end of that. So you can see that data runs through up until the 30th of July, 2018. Now, in this next step, this is where we're going to fit our profit model. So very simply, all you'd need to do to instantiate the profit class is just create a variable name called profit. Just to point out a few things, again, because it's a class, we can use this help function. And so help parentheses and then profit. And then we've got the documentation, which you can have a look through here. The other thing you can do, if you go into the parentheses of the profit here, shift tab, it opens it up. Now, there are quite a lot of things to change. Do not be put off by that. The whole idea of profit is it's meant to be automated. So you probably don't need to start playing around with these, and that's the whole idea. But there are a couple of things that we recommend having a play with, and that would be setting your prediction interval. By default, it's 80%, but if you want to increase that to 95%, you can do that. And then also just specifying that daily seasonality is false. So that's where you're telling it there's not, we're looking at daily level data, not hourly level data. It will prevent an error appearing on the screen. And then all we're going to do is we've instantiated that model, and then we're going to fit the profit training data, which we just created. Now, depending on what operating system you're using, this may look slightly different. You may get additional text at the top, but what we're most interested in seeing is model convergence convergence has been detected. So that's great. It has been able to fit the model. So now we've fit the model and that's ready to go. But in order to get it to populate some predictions, we actually need to pass it in a data frame that has space for those two predictions to be populated into. So what we're going to do is make this future data frame, and we're going to call it future. And we'll do this by calling the model.makeFutureDataFrame, and periods is 28 because we want it to go 28 days into the future. And then if we have a look at that, we can see that's given us an empty data frame, remembering that the old data went up to the 30th. Sorry, let me just have, I'm sorry for the scrolling. Yeah, we go up to 30 July 2018, and then you can see the future data frame picks up from the 1st of August. And so runs into the future. And then because we asked for 28 days, it goes until the 30th. Sorry, I'm going back a step. The training data went up until 30 July, sorry. Now next, we can then predict, and we're going to pass in this future data frame. So this is just the data frame with just the dates alone. That's what we're going to pass in, and that's make profit go, oh, so you passed in the DS column, I'll populate the Y column for you. So if we have a look at that, it then just takes a second, and you can see it actually comes out with an awful lot more information. So as well as the DS column, we've got our upper, Y hat upper and Y hat lower. So these are upper and lower confidence intervals. We've got our trend, additive terms, so on and so forth. So it's got quite a bit of information there. But the thing we're most interested in, our point forecast, is this Y hat, which is the value which we populated at the far right. So we can see here it would be 19.1 for that first date. And I'm looking at the end of that same data frame, obviously all the same columns, and at the end, towards the end of that period, it would expect 42. So next we want to plot the fitted values against the forecast. And to do this, we'll just use model.plot and then pass in the profit forecast. And again, just a reminder, dark blue are the point forecasts, light blue are the prediction intervals, black are the training data. And so you can see that runs up to here. And this is our final 28 days that we predicted at the end. So we don't have the training data to compare back to. But if we wanted to make this interactive, which I think would be a little bit easier because you might want to zoom in and see what's going on here, we're going to call this plot plotly function, and we'll pass in the model and the profit forecast variable. And when we do that, you can see we've got our entire timeline here. But if we wanted to look at the last 6 months, we just click on the 6M at the top, and it's zoomed in and it's grayed out the area we're not looking at, leaving this active area. We can then zoom along, and this allows us very easily to kind of get in nice and close and see what the prediction actually looks like. So that can be quite useful for looking at the historic data as well. And if I want to see it all, I'm just clicking on all again, and then you can zoom in to your heart's content. So the next thing we're going to do is plot profits components. And so we're just going to save this to a variable AX, model.plot components, and then passing in the profit forecast. And so again, we've got our overall trends here. So we can see definite change point here, another one probably here. We can see our day of week seasonality. So Sundays less than Wednesdays, so Wednesdays being the peak. We've then got our kind of monthly seasonality throughout the course of the year with the sine and cosine rule waves, or the Fourier series. And again, we can also make these interactive with the plot components plotly, and then passing two variables. And if you want, I can zoom in to any part of them, and then, ooh, no, that's not what I wanted, sorry. Yeah, zoom out, zoom in. So it just allows you to kind of move in accordingly, so you can have a closer inspection of the particular data of interest. So hopefully that is all relatively straightforward. And then finally, for the third code along, we're going to see about adding these holidays. So this is one of the real benefits of using profit. So again, standard library inputs here. We will then add in our plot components as well. And again, we do want to be on version 1.1. Sorry, 1.0. We've got this utility function for the profit training data to give us the format that we need. And again, we're going to read in this respiratory admissions data. That's great. So looks very familiar to before. Now we're going to add in the holidays to it. So we're going to instantiate a brand new model. We're going to set we want our prediction interval to be 95%. We haven't got the daily seasonality, so we'll set that value to false. We are then going to call the add country holidays method, and we're going to specify the country name UK. And then, because we've added that to model, we'll then fit the model based on that. Now, it's interesting because the country name used to be able to put England in there, and it worked. But when I tested this the other day, something's changed in the last couple of months, and it has it breaks. So obviously, this covers all of the holidays in the UK, but as we know that Scotland may observe holidays that England does not. I think GB. I've just literally read something as I was getting ready to come back on this afternoon. So GB does work. So again, feel free to alter the code and use GB when you're working in the exercise. And so if we wanted, we can then have a look at what are the holidays that have been included when we've added holidays for GB. Oh no, it looks like it still includes Ireland, Northern Ireland, but we can see basically from the model, the trained holiday names, we're just sending that to a list. So we've got New Year's Day, and then New Year's Day Scotland, the one that's observed, St. Patrick's Day, Northern Ireland, so on and so forth. So it has, as I say, all of the holidays identified here for all the years, and so if it's able to correlate these events with a higher value, then obviously it can incorporate that into its future predictions. So next we're going to make the prediction and analyze the components. So we're going to create our empty future data frame. So model make future data frame, and we're going to look at 84 days, so 3 months into the future. We will assign the this new prediction to profit forecast. It'll just take a second to run. We'll then have a look at those components. Then we can see our change points. We can see our uncertainty start to grow towards the end. And then for our holidays, we can see that, certain holidays, when that'll be, that's probably around Christmas, New Year, that causes a big spike. And then there's other periods, maybe this could be Christmas Day, for example, causes a reduction one, or sometime in December. And so you can see these different holidays are attributed to big spikes, either positive or negative. Then we've got our day of week, and then monthly seasonality. Now, obviously, looking at this, it's quite hard to unpick, well, what data is having what impact. So it is possible to specify and have a look. And so if we wanted to look at just Good Friday from that list, we can see that our Good Fridays actually tend to have lower than expected values. So again, can be quite good just to have a look and identify exactly where your differences are coming from. Then, if we wanted to work with the interactive versions, we'll just call plotly, model, and pass in model and forecast. And again, we've got that there. We want to look at our components. Again, we can look at that in the static view. If we scroll down, we can do it in the interactive version as well. Allows you to zoom in. Oh yeah, Christmas Day, New Year's Day, and then New Year's Day Scotland. So again, quite nice with this plotly version where you're able to zoom in and have a closer look at what's going on. As I say, you get the holidays that come out of the box, but then you also have the ability to add your own holidays in. The caveat with that is that you need to know the dates that they fall, so may require doing a little bit of research. But let's see if our data set is impacted by Black Friday sales. Interesting theory. So what we have to do is create a new data frame called Black Fridays. And so we'll give it 2 columns. One column will be just an identifier, which will be holiday and Black Friday. And then each value within that data frame under the DS column will then have the Black Friday label applied to it. So we've got all the Black Friday dates here from 2014 to 2025. No, it's not. That's from, let's see. Sorry, yeah, 2014 to 25. I was looking at the day at the end. So we'll run that, and then you can see it spits out a nice data frame. Each value, each row has the same value for the holiday label, and then we've got our data frame. And the reason you want to add that label is because that when you add it in, if you then wanted to spit out all the holidays it's considering, you want to make sure that it identifies that, it's not just a blank random holiday, it associates with Black Friday, because all the labels that it adds automatically, they will all be labeled for you. And so next we are going to, I'm just going to put some spacing in to make it a little bit easier to use. We are going to instantiate a brand new model, 95% prediction interval, no days intraday to seasonality. And our holidays, we're going to specify this new argument, and we're going to assign Black Friday. So that new data frame we created there. Obviously, that data frame could be variable length. As well as the Black Friday holidays we're going to add the ones out of the box for UK or GB. We will then fit the model with that profit training data. We will make a future empty data frame for the future forecast, and then we'll predict by passing in that future forecast to get our profit forecast. And then we can see that it's convergence detected, which is great. We'll spit out the list of the holidays, and you can see the first entry in that list is that Black Friday one that we've added. So why it's so important to label it. And so let's have a look and see because we can identify single holidays to see what impact it has. If we look, well, we can see, even though these spikes look enormous, if you actually look at the values of the spikes, Black Fridays, just over half a call more, not that great really. So yeah, probably not worth adding, and in actual fact, I'll probably ignore that, and in future wouldn't bother adding it in the first place, because I don't really think it's having any value. And the problem with adding holidays that aren't adding any value is that you, as I say, it forces Profit to try and use it, which can actually just make the data a bit more wonky. So any questions about any of the 3 code alongs we've just had a look at?
Yeah, that's one question. So with the trend, can you put in your own trends? Like, so for example, you say a scenario where service is like, we're going to grow by like 10% next year. Can you kind of force it to use that 10%, but then apply the seasonality like additively on top of that, or does it have to automatically use the trend from historics?
As far as I'm aware, it automatically just uses the trends. However, that is a good question. I will, while you're working on that exercise, I'll have a look and see if there's a way to manually force, your own predetermined trend. For whatever reason, if you think you know better than it does, that's an interesting question. So I'll come back to you on that one.
So a lot of the examples have used data that kind of stops at 2018.
Yeah.
What do we do about COVID?
Yeah, great question. Basically, it is a very real problem, and I think it's a case of looking at, look at the time series for the data that you're going to be looking at and seeing how much COVID did or did not impact it. And for certain things, you may find that actually it kind of got back to an even keel relatively quickly. And so you may have, the whole of 2021 and the whole of 22 to train it on. And again, it's worth having a look at and just seeing what the prediction intervals are and how it looks and feels, and even forecast ahead for a week and then look 1 week later, compare what actually happened against what was forecast. Or it just may be that actually things have been so off balanced that you just can't use it at the moment. Unfortunately, it's a very real problem. All of these techniques do rely on a baseline of statistical wizardry in the background to get to that point, and so unfortunately, without the core data on which to kind of use the statistical hypotheses, you are somewhat lost. So I don't know if that's the answer you wanted or not, but yeah, it's trial and error basically, and just see what is the minimum amount of data you can use to get a prediction that looks like it's reasonable. And again, it depends what you're using that prediction for. If it was mission critical or really making very big decisions, I'd be very, very wary and be putting huge disclaimers on this. Similarly, you could have a look and see, we've got all the data till 2020, then it all went crazy, and then if it's come back, and looking at the part that's come back from, you may want to consider just chopping out that bit in the middle to see if that helps or not. But again, it would be a trial and error and just seeing what you feel comfortable with.
Okay, great, thank you.
Cheers.
Okay. Oh, sorry, I was just going to ask about the gaps. So can you do data gaps? You just got to it at the very end. Does it deal okay with gaps in the data?
Well, not really. So what I would propose is literally, I would probably look at the pre-data in isolation, then look at the, cut out the middle, and then look at the right, and maybe even do it visually and go, well, visually, does this look like it follows a similar-ish trend or not? Because let's say that something actually has the mean, the average is constant, its standard deviation doesn't vary too much, and it doesn't have that much seasonality. In actual fact, it just kind of does this, and it might just keep doing that ad infinitum, in which case I'd be quite confident of doing it. But if it was kind of showing year-on-year increases and then obviously COVID spread off, and then it's coming back and it's now down here and maybe doing a downward or kind of level, then I would say it's inconsistent, and I wouldn't even bother trying to see if it could marry up.
Yeah, I meant more like if you've got like a data flow issue, you know, you lost 2 days of data or whatever.
Right. I think off the top, I'm going to double check to give you an accurate answer, but I think at a minimum you'd have to impute the missing values, because otherwise, if they were just 0, that would see that as a bit of a trend, and it may think there's a reason for that, and it may try and fit it somehow. So yeah, I think you may have to put average values in, and then again, it depends. If you have 2 missing values out of 3 years, probably not so much of a problem. But if it's 2 missing values or 2 months of missing data out of 12 months their worth, then that is going to be a much bigger issue. So it all depends, you know, kind of like machine learning in general, what percentage is you missing data as a value of the whole loss of it.
Thanks.
Cool.
I just had one question, Elliot, sorry,
Yeah,
about
sure.
the holidays. It's similar to the COVID question. I was thinking about the strikes. Does a holiday have to be recurring, or could you put a holiday in that only happens once just to identify a special day?
Apologize me scrolling, but you can do it only once. Yeah. The only issue is it in the past or in the future? Because the reason you have to put the historic in as well as the future here is so it knows historically these things happened on this date, and in the future it's the same event, so we'd expect a similar pattern. If it's only ever happened once, it's got nothing to compare it to, if that makes sense.
Yeah. Okay. Yeah. Thank you.
Cool. All right then. So I'm going to open up the peer support group rooms, and we will have everyone, I think, should have a 20-minute break now, and then roll into 60 minutes of the exercise. So we will regroup in 80 minutes, 1 hour 20. My maths is really good. We'll come back at 3:40 if that's okay. And I'll be floating around the rooms. Any questions, please just let me know. Cheers. Thank you. Hello, everyone, and welcome back. Hopefully, there was not too many issues with that, and it was relatively straightforward, apart from obviously all of the environment issues that some of you have been suffering from. But I just thought for the remainder of the session, just to give you a heads up what I was planning, I'll run you through the solutions for the exercise, which of course will be published immediately. At the end of that, what I've been doing in this off time, I've actually used the implemented the auto naive method to find out which will be the best naive method to use for this data set. And then I've compared the Facebook's or the profit accuracy against the ensemble method, which is what the auto came out with. And again, that's saved in there. So if you didn't want to hang around, you will be able to access that. It will be at the end of the solutions file. But other than that, I'll get going. Once I've covered that, I just want to cover a couple of things related to the Python assessments and also the projects. Again, so general points, just pick up on chats that I've seen going on. And then the final thing, which is entirely optional, absolutely, you do not have to stay for it. It's not assessed, it's not shown anywhere else. It's just something that I personally found useful. And just because we've had a bit of conversation about environments today, I just wanted to show you and explain how Binder Hub works. Because Binder Hub may be a really fantastic way for you to show people within your organization the applications or things that you've built in Python without them having to download or install any code on their machine. So you could use it for machine learning models at a push. But it's a really great way to share, as I say, bits of programming that you've done with other people in the team. That part will be entirely optional. You're not obliged to stick around for that. So if I'll just get going on this. So obviously standard library imports, the profit imports. I know that some people were using a later version. If that caused any issues or things weren't working as expected, please let me know. I have put a link into the Module 9 Slack channel forecasting. So if anyone who's had any issues, if they could please just fill in that form, it'll only take 2 seconds. It's just so I can make sure I get everything working for next year. And I'm just going to put it into our chat here now as well. I'm going to try to. Cool. Right. Oh, thanks, Nick. I've just seen 1.1.2 seem to work for everyone. So anyone has any issues with environment at all, please fill in this survey. It's only a couple of quick questions. I don't need email addresses or anything. It's just so I can get a feel for things. But then, obviously, we've got our other imports. We then load our ED reattendance data, and we can plot how that looks here. We then wrangle the data into the profit format using the use defined function, profit training data, and that spits out our 2 columns. Now, something I noticed there was an issue. If you try and plot this YP train, it's not just going to plot the Y value as you'd expect to see. It'll try and plot this DS column as like a value in its 2000s. So you'll have 2 straight lines, or what look like straight lines. If you just wanted to plot just the Y, you have to specify that Y column. Next, you'll be fitting and predicting your profit model. So we'll instantiate profit with a interval of 0.95 to 95% prediction interval. You'll notice I didn't put the usual daily seasonality equals true on the screen here. So if I add that in here, run it again, you see the error disappears, and that's because we don't have intra-day seasonality. And then next, we will fit our YP train data to the model. And then we can see our convergence detected, so it's all good. Then we'll scroll down. We'll make our future data frame. So we're going to do a 3-month prediction into the future. So that's just going to be model.make future data frame periods equals 84. Then we can see those 84 rows are appended to the end. We will then predict the future on the model and saving that to a variable called profit forecast. And then we can see all of our lovely columns there and our values on the right-hand side ranging from 191 through to 202. We can then plot that. And you can see this is the non-interactive version. Our 3 months are added at the end. If we want to plot the components, we just use the dot plot components. So we can see our trend from early 2017 onwards. We have a downward trend and a relatively tight diffusion at the end. We see our day of week seasonality. So Mondays tend to be the busiest days. Thursdays the quietest. Looking at the monthly seasonality, just after July, so kind of summer holiday time tends to be the highest here. We then add in our custom holidays for the UK. Apologies, it still says England up there. But then we run this again. We can spit out the holidays we're going to look at. And then again, using the decomposition model, and then we can look at the holidays as specified. Scrolling down, if we look at the columns for the different holidays, I've used that to identify which holiday I want to pull out one at a time. So we can see that on Christmas Day, I've just seen the comments about plots being plotted twice. Interesting one. So with Christmas Day here, we can see on average, they're about 50. You have a value 50 lower than the trend. So that's quite interesting. So it tells us that Christmas Day does have an impact for this particular model, as does Easter Monday. And here I had to call it explicitly as it's called within profit. So I had to add these England, Wales, Northern Ireland jazz, which is a little bit annoying. Good Friday has a uniform name across, and yet that has a positive impact. And then just below, I've added the day of month seasonality. So that's by adding this row here. And again, you've got the output plots here. And then we found, because we've got that day of month seasonality, you can see that, around the 23rd, would probably be the busiest day of the month in general. It would have a higher prediction. Okay. And so that is the end of the solutions file. But as I said, just to kind of illustrate it and show how you would then say, well, how good is Profit at predicting compared to some of the other methods? I've just taken the Y-train data, so the original data set. I then split it up into YP train and YP test. So I'm using that Profit training data, so that's where it creates the DS and the Y column. And I'm using all but the last 28 for the train, and then the final 28 for the test. And that shows that we had 1,550 data points, and then we split it to 1,522 for train, 28 for test. I then imported the libraries required for the auto naive to find out which method's the best. And so to do this, again, just taken from the documentation from the link I sent earlier, a new variable called best, and use the auto naive function, passing in the training data being all but the 28 on a horizon of 28 days, and the seasonal period is 365 because our data is daily data. And that tells us the best method is the ensemble naive, which is an ensemble of the naive methods, and that gave a mean absolute error of 22.1. So then I'm then going to import the ensemble naive predictor. And again, I'm going to instantiate that again because I'm using daily level data. I put 365 here. And then I'm going to fit and predict with the training data for 28 days. Then I'm going to create a Facebook model, a profit model, and put in that same Y profit training data, so all but the 28. Then I'm going to assess the using the forecast errors to look at the training data against the profit data. So for this, I'm out of the profit forecast. I'm just pulling out that one column, which is Y hat, and I'm just looking at the last 28 rows of it. I'm putting it into a list, and we can see here the mean absolute percentage error is 7.6. Whereas we compare that against the ensemble method, the ensemble is not that much higher at 9.14. So it just goes to show you, even though it seems a lot more advanced, you know, it's only a couple of percent bigger or better. So therefore, you know, which one is worth the effort and what is the ultimate intended use for these forecasts. So again, just some food for thought for you. And I thought it was just quite good to close that loop at the end and then provide the code for people to use if they were going to go and do any forecasting. So any questions at all about any of that?
Just a bit strange that they were doubling up on the graphs.
Yeah. I'm trying to think about that one. Out of interest, was that on a local environment or Binder Hub?
Local.
Okay.
Ours on a bind.
Oh, okay. I thought I tested everything on the Binder Hub. Right. Let me have a look at that, and I'll come back to you. So just for a bit of background, originally there were two separate environment files, 9A and 9B, and I thought I'd just try and be smart and merge it into one to avoid people having to do it twice. So I just used the best version numbers out of both. And as I tested it on my machines and I didn't have any issue, but that was a couple of weeks ago now. So I'm just wondering if there's been any version updates. So I'll do some digging and I'll make sure I get that fixed definitely for next year. And then again, if anyone is doing a forecasting or incorporating forecasting into their project, we'll get the answers for you to make sure it's not going to cause you any issue when you're doing this for real. I'm not sure about the assumption about the independent errors. I will make a note of that and get back to you. I'm afraid I don't know the answer to that one off the top of my head. Cool. So if there's nothing else, I just briefly wanted to mention a couple of things just with regards to the assessment and the project. Dan had to start off, so I'll try and keep it brief. But basically, obviously, next Tuesday is the assessment for those who are taking it next Tuesday. Just to remind everyone, it is only on the stuff we covered in Module 1. So you don't need to know about forecasting or network analysis or geopandas or anything like that. It's just on the core basics. I would tell everyone to have a go at it, regardless of whether or not you intend to put a project in. If nothing else, it is a good way to see what you've learned and may identify areas you may want to go back and look at in the future. It's not formally assessed as such. The idea is everyone does it. And again, I'll do it for your own personal learning. If you're not doing a project, then you put a project pitch forward. If your project is picked, we will then look at the assessment just to make sure we think you're going to be confident and comfortable enough to lead a project, especially if other people are going to be involved. But it is not meant to name and shame. It is a lot of fun. I think I can say it's based on a TV show, but I thought it's really well written and it's a really good assessment. If anyone looked at the prior year assessments, I found it personally much better, a lot more fun, and I think it tests a bit more of a breadth of skills and things taught in Module 1. So hopefully you'll all find it very enjoyable. The other thing to note, so I'm just reading my notes here, is if you really can't come up with an idea, but you're more than happy to assist with someone else, why not, kind of advertise yourself within either your peer support groups or project ideas, and maybe specify the organization you work for or the locality that you're in. I don't know if people saw it earlier, but there was a query about data sharing agreements and all of that. And it's not necessarily always required. You may be working on a project where if you're supporting, you may be able to work on a distinct part of it, which doesn't actually require any data at all, or could be, some anonymous data could be generated very easily. And that would be all you'd need to help feed into it. So, don't worry too much about that. There are more than one way to skin a cat. Yes, the prior year assessment, I'm fairly sure is public domain. I will just confirm that and put an announcement out tomorrow morning. I thought it had been published previously, but unfortunately, and this brings me on to the next point, as a lot of you have started to see now, Slack only has a memory of 90 days because we are on the free version. We do not pay for it because it's quite a substantial cost because you pay per user, and we're all about free and open source. So if you do see links and things that you like pop up in your peer support groups, chats, main channels, try and save them locally on your machines, just because after 90 days, everything gets purged, and that's on a rolling basis. Thank you very much. I'm loving that people are able to help each other out with the answers here. That's great. And just something else to note, there are, if anyone kind of has forgotten or doesn't remember seeing them, there are links on the YouTube channel to prior year project showcases. So these are the showcases that's done at the end of projects, and people talk about what they've done, who they work for, the type of obstacles they came up with. I can post a couple of those very quickly. I've got them at my fingertips. Again, have a look at those. It may give you some ideas, but hopefully you're all got your thinking caps on now, and you'll be ready to record those pictures, ready for Dan and I to watch, and obviously you'll be doing a little bit of preparation for next week's assessment as well. Any questions about any of the above? Okay. So as I said, the final thing I was going to show everyone, and again, this is purely optional. It's purely because it was something that I only learned about not that long ago, but I do think it can be quite useful. And this is just about how to, if you've done some code and you've got something working and you want to share it with other people within your organization via Binder Hub, this is how to get it working. So I've come up with a very, very, very basic proof of concept just to show you. Again, I'm happy to share the code. Sorry, I've just seen a question. What happens if you don't pitch a project and can't join anyone else's? Well, then it's goodbye. You know, after the formal sessions have ended, we will be having masterclass sessions. The duration will be 1 to 3 hours, kind of lunch and learns, or maybe a bit longer, and we'll be talking about different topics, just, you know, like using Streamlit apps or other bits and pieces, which may be like what I'm just about to show you, just little things that may help augment or improve projects, or at the same time just adds to everyone's general learning ability, because hopefully everyone will go away, and even if they don't put a project or work on one, hopefully they will, you know, use some of what they've learned in HSMA, and these additional masterclasses are just to kind of upskill everyone, and maybe give you some flavor of something that you might go on and do in the future. So they're not as big as full-day training sessions. They'll be much more reduced, and so you'll get given code but given some explanations as well, just to make it a bit lighter, but also very, very practical and hands-on as well. So hopefully that answers that. So just with regards to what we would do for Binder Hub, I'm just closing this. So basically, I have come up with this folder structure. Hopefully everyone can see this. So I've just created a new folder on my desktop, and I'm going to call it Binder Hub Tutorial. Within that, I have a notebook file, ingeniously called notebook.ipynb. We have a data folder. Inside there is data. That doesn't have to be there. The only thing that really needs to be there is this folder called Binder. We look in there, there's this environments.yml, which must be called exactly that, all lowercase. And inside that, it follows a relatively standard format. And for this particular environment, it's not very complicated. I'm just going to use Jupyter Notebook, NumPy, and Pandas. So that's all saved. And so what you need to do to get that on Binder, or get a Binder environment going, is actually to upload it to something called GitHub. Now, Git is a version control ecosystem, and Dan will be talking to you about it, and no doubt it will leave lots of people pulling their hair out. But GitHub is an implementation of it, and the best way I describe GitHub to people, it's kind of like Dropbox for those who use it, but you can use command line interfaces. So what I'm going to do is create a new folder, or what they call a repository, on GitHub, so like a shared and open Dropbox folder. I'm going to upload these files and directories into it. So in github.com, I've already got an account. I'm just going to create a new file, and we'll call it Binder Hub Tutorial. And again, don't worry too much about how to use GitHub. This is just more proof of concept. Make sure it's set to public, and I'm going to create this repository. Once that's done, I will then need to upload an existing file. So I'm not using any of the command line interfaces here. Upload the file, and I can drag and drop, which is good news for me. So I'm going to drag in my notebook. I'm going to drag in the data folder, and I'm also going to drag in the Binder folder. And then I'm just going to do what's called commit changes. And this is basically saying I want to make these changes public and available to everyone. Upload complete. You can put anything, this does not matter. I'm going to commit the changes. And then this will just take a moment to upload. And we can now see in this Binder Hub, so if I put this in the chat window, any of you can navigate to it. You can go in and you can, just like every other GitHub repo, you can download it and play with it. But now what I'm going to do is copy the URL at the top. Then I'm going to go to binder.org. And when this page loads, I'm telling it that I'm going to use a GitHub repository to build my online environment. I'm going to paste in that URL. And you'll see at the bottom, I then get this URL, and it looks kind of familiar. It's got Elliott HSMA, Binder Hub Shoot, and then it's put head at the end. So I'm going to copy that, but I'm then going to hit launch. And what this is going to do, and sometimes my machine is a little bit funny because it seems to ping the servers a bit too often, but hopefully it'll build. The first time it reads it, it's going to go to GitHub, and it's going to have a look at the files. It's going to import them, and it's going to create what's called an image. which is imagine a tiny little operating system that only has in it what it needs to run to get the online environment. So the three packages, Notebook, Pandas, and NumPy that I had in the environment file, and a few other things that's going to need to work. And then once that's done, this will load gradually. But essentially, you ultimately paste that URL into a new window. And this is kind of going to be doing the same thing simultaneously. Every time you paste that in, it will ping, it will go to GitHub and say, are there any changes since I built that image? If there are, it will rebuild the image. And if not, it will just pull the image that it's already created out of its archives. So I don't honestly know how long this will take. I'm hoping it's not too long. But once this is loaded, it will then look how it looks when you load the Binder Hub links for the sessions every Tuesday. And you'll see the notebook file. And within the notebook file, it's just got a couple of commands. It's literally import pandas and read in the data from a CSV located in the data repository. So again, this is very, very simplified. However, as you can imagine, as I've done for today, probably not the best example, but you know, for network analysis and even with all the Folium and GeoPandas stuff, it's meant that I've been able to share with you environments with lots of packages in without you actually needing to install anything on your machine. Even though a lot of you have created the environments locally, you didn't need to. So that would mean anyone within your organization who had access to a web browser and binderhub.org would be able to get access to potentially a notebook that you've created and then published once you're happy to share it with people. And again, no obligation to share. It's only if you choose to do so. Okay, so too many users, try again soon. So you're just going to have to take my word for it. It will load like kind of a Jupyter Lab. So you'll have the directory and folders on the left-hand side. You click on it and you'll go into it. But hopefully that is quite clear. I do appreciate I've been talking exceptionally quickly. I don't know if anyone has got any questions at all, or if that's might be better to watch on a recap of the video. All right. Well, in the absence of anything else, I will leave everyone in peace. I will look up that question about the independent errors and get back to you, and also do a bit of investigation, read the environment. So if everyone can complete that Google form, it'll just take a couple of seconds. I would be eternally grateful. And yeah, maybe check back tomorrow on this link and you'll see how this Binder Hub will look. But other than that, I hope you enjoy the extra 25 minutes you've got in your day. Have a fantastic week. Good luck with the assessment next week. Again, I would encourage everyone to have a go. Yeah. And any other questions, please get in touch with Dan or I. Other than that, have a fantastic week and take care.
Thank you, Elliot.
Bye now.